Okay, boys and girls, so this is the equation of force. So you can say that here, boys and girls, you can say that here, force. Here force is the product of, force is a one kind of physical quantity which can able to change the state of motion of any body. Is known as force. So you can say that at the definition of force part, you can say that here this is a particular physical quantity. Okay, and this particular quantity can able to change the state of motion. Now, the another definition of force is the product of which quantity? Force is the product of here mass and acceleration. Boys and girls, I can say that force is the product of which quantity? This is the product of mass and acceleration. Now, the equation of force will be equal to F equal to ma. In the next step, I'm going to find out the unit of force. So, unit of force. Unit of force. You see here, the basic equation of force will be equal to the product of mass and acceleration. So here F will equal to what? F will equal to m into a. So you can say that the unit of force depends on which quantity? We can say that here the unit of force depends on number 1 mass and number 2 acceleration. What? Number 1 mass and here number 2 acceleration. So the unit of mass is, you know that very well, it is kilogram or kg. Now you can say that the unit of force, the unit of force is, sorry, the unit of mass is kilogram or kg. And you also know that from previous chapter, the unit of acceleration, the unit of acceleration is meter per second square. Meter per second square. Now, what should be the unit of force? You can say that this force is the product of here since mass and acceleration. That's why the unit of force is nothing but the product of kg meter per second. So the unit of force is nothing but it is kg meter per second square. So kg meter per second square is nothing but the unit of force. I repeat, boys and girls, kg meter per second square is nothing but the unit of force. You see that it's a very complex quantity. You see that kg meter per second square is a very complex quantity. Okay, so scientists try to simplify this and give reward some other scientists. Okay, you see that the basic definition or the mathematical definition of force is given by scientist Newton from Newton's law of motion. Okay, so to give respect to Newton for his Newton's law of motion, the SI unit or the compound unit of force is shortly presented by Newton. And you can say that from here 1 Newton will equal to 1 kg meter per second square. I repeat, here 1 Newton will equal to what? It will equal to 1 kg meter per second square. Okay, so finally you can say that the SI unit or the basic unit of force is Newton. Now, boys and girls, in next step, I'm going to know some mathematical function about force. Explain some amount of force. Okay, suppose if someone said that on a particular body 10 Newton force is applied. So what do we understand by this 10 Newton force? So I can say that on a body if 10 Newton force is applied, what do you understand by this? What do you understand by this? Understand by this. What do you understand by this? Okay. So here it's written in the question part is on a body if 10 Newton force is applied, then what do you understand by this 10 Newton force? I repeat, then what do you understand by this 10 Newton force? You see this, to explain this 10 Newton force, you need to know very well about the mathematical formula of force. You see that from the mathematical formula of force here, force is the product of mass and acceleration. So you can say that force F equal to m into a. So force equal to what? Here force equal to mass. Here force equal to mass and acceleration. Here force equal to mass and acceleration. Now force is denoted by F, mass is denoted by m, and acceleration equal to a. The product of m and a should be 10. Boys and girls, the product of m and a here should be equal to 10. So I can say that if a body of mass is 10 kg, what? If a body of mass is 10 kg, and then on the particular body, if I'm going to apply a force on it, and because of that particular force, the acceleration of the body is 1 meter per second, then the product of that m and a will equal to 10 into 1 is nothing but 10. So we can say that the body of mass will equal to 10 kg, and on this particular body of mass 10 kg, I'm going to apply a acceleration on it. Okay, so the acceleration A will equal to if 1 meter per second square. If it is 1 meter per second square, then what should be the product? The product will equal to here 10 kg meter per second square. The product will equal to what? It is 10 kg meter per second square. Okay, so will equal to 10 Newton. Now I can say that 1 kg meter per second square will equal to 1 Newton. So it is very clear to you that the applied force on a body is 10 Newton. The applied force on a body is 10 Newton. By this we can say that, a body of mass 10 kg, a body of mass 10 kg, and on the particular body of mass 10 kg, we are going to apply force on it. And because of that force, this body will go at 1 meter per second square acceleration along the direction of force. This body will go at 1 meter per second square acceleration along the direction of force. So this is the explanation of 10 Newton force. Now this is all about discussion about force. Now I'm going to discuss a creative question on the basis of force. Boys and girls, now I'm going to discuss about a creative question on the basis of force. Now let's see. Okay, so creative question. Now, creative question on the basis of force. Boys and girls, this is a body at a particular place A. This another body at a particular place B. The mass of the body M equal to 5 kg. Okay, the mass of the body M equal to 5 kg. Now, I'm going to apply force on this body. Apply force on this body, so F, and because of this particular force, initial velocity of the body U will equal to 5 meter per second becomes here final velocity V is 10 meter per second after t equal to 5 second time. After t equal to what? After t equal to here 5-second time. Now we are going to solve the creative question on the basis of force. My first question, question number 8. What is called force? What is called force? Now question number B. Now what? Question number B. What do you understand by 10 Newton force? What do you understand by 10 Newton force? And then question number C. Calculate applied force on this body. So calculate applied force on this body. And then question number D. If final velocity is 15 meter per second, then are there any variation of force? বাবা ওইদিকে যাও বাবা, দাদির কাছে যাও, দাদির কাছে যাও। Explain mathematically. Explain mathematically. তাহলে কোশ্চেনটা হচ্ছে কি? কোশ্চেন নাম্বার হচ্ছে A. A number question is what is called force? Now question number B. What do you understand by 10 Newton force? And then question number C. Calculate applied force on the body. Calculate applied force on this body. And question number D. If final velocity is 15 meter per second, then are there any variation of force? Explain mathematically. Okay. Now, in my previous lecture part, I just already discussed about question number A and question number B. And now I'm going to discuss about question number C. How can I calculate this amount of force on the particular body? You see here, in question number C, the body of mass M equal to 5 kg. On the body of mass M equal to 5 kg, we are going to apply force. And because of the force, its initial velocity, starting velocity 5 meter per second becomes 10 meter per second after 5-second time. Its initial velocity 5 meter per second becomes 10 meter per second after 5-second time. After how long? After here 5-second time. Now from this stem, I'm going to calculate the applied force on it. So given that mass of the body M will equal to 5 kg. Initial velocity U will equal to 5 meter per second. Final velocity V will equal to 10 meter per second. And time t will equal to 5-second time, and time t will equal to 5-second time. Now, before calculating force, at first we are going to calculate about the value of acceleration. I repeat, about the value of acceleration. You see that we have to find out at first force F will equal to what? We know that. We know that. What is acceleration? Acceleration is nothing but rate of change of velocity. So what do you understand by rate of change? Rate of change means what? Change of velocity with respect to time. I repeat, change of velocity with respect to time is known as rate of change of velocity. So we know that acceleration will equal to change of velocity by time. Change of velocity by time. Now, boys and girls, change of velocity A will equal to what? Acceleration equal to A. And then change of velocity equal to what? You see that change of velocity is nothing but v minus u, because you see that here v is the final velocity and u is initial velocity. I repeat, boys and girls, here v is the final velocity and u initial velocity. So the change of velocity will equal to v minus u. So it will equal to here v minus u divided by time t. Divided by what? Time t. So here v equal to 10 minus u equal to 5 after 5-second time will equal to 1 meter per second square is the acceleration of the body. I repeat, 1 meter per second square is the acceleration of the body. Now you are going to calculate applied force on it. How can you calculate it? You know that very well. Applied force is nothing but the product of mass into acceleration. So applied force F will equal to what? Will equal to m into a. Now the body of mass m equal to 5 kg. Here I'm just taking a body of mass m equal to 5 kg. So here m equal to 5 kg. And then acceleration of this body a will equal to what? Acceleration of this body here a will equal to 1 meter per second square. So a will equal to 1 meter per second square is nothing but 5 Newton. So here applied force F is, I repeat, here applied force F is 5 Newton. So boys and girls, this is all about answer C. So at first we're going to find out acceleration on this body. So it is v minus u by t, and then acceleration becomes here 1 meter per second square. And then you see that force F equal to ma. So m equal to here 5 kg, a equal to 1 meter per second square. So the applied force F is 5 Newton. Now in question number D, you see that if velocity is, which velocity? Final velocity. If final velocity is 15 meter per second, then are there any variation of force? Which force? Applied force. Okay, you see that in previous case applied force is 5 Newton. Now in new situation here it is, if final velocity is 15 meter per second, then are there any variation of applied force? So from here applied force or the value of applied force can vary or not. We're just going to justify this. Okay, so explain this with mathematical logic. So to solve this problem, again we're going to write down some given information and then we're going to solve this math. Boys and girls, and then we're going to solve this math. Okay, so you can say that this is question number D. final velocity v equal to, for this question it is 15. It is 15. So I can say that the first one, mass of the body m equal to 5 kg, initial velocity u equal to 5 meter per second, initial velocity u equal to 5 meter per second, final velocity v equal to 15 meter per second, and time t is 5 second time. Boys and girls, and time t is 5 second time. And now I'm going to calculate the force. So force F equal to what? We know that acceleration A is change of velocity by time. Acceleration equal to what? It's nothing but change of velocity by time. So acceleration is denoted by A. Acceleration is denoted by A. And change of velocity is v minus u by t. Okay. New acceleration becomes a1 and new velocity becomes v1. Because you see that in this particular case, final velocity only varies. So it is v1 equal to 15 meter per second. And other thing remains same. So here v1 equal to 15 meter per second. So v1 equal to what? 15 meter per second minus u equal to 5 by 5 will equal to 15 minus 5 is 10 divided by 2 is 2 meter per second square. Okay, so this is the value of acceleration in the situation given in question number D. So applied force F1 will equal to m into a1. Why a1? Because final velocity changes here, and since final velocity changes here, that's why applied force also changes here. Okay, so m equal to 5 kg, 5 kg, a1 equal to 2 is nothing but 10 Newton. So you see that in previous case acceleration is 5 Newton. In previous case acceleration is 5 Newton. In this case acceleration is 10 Newton. So what is the change of force? Sorry, in previous case force is 5 Newton exactly, and in this case force is 10 Newton. So then what is the change of force here? So I can say that the change of force will equal to F1 minus F is nothing but what? New force is 10 Newton, previous force 5 Newton will equal to 5 Newton is the change of force. So you can say that when final velocity is 15 meter per second, then what is happening here? Then force changes, and the change of force is nothing but 5 Newton. Now I'm going to give you a homework creative question on the basis of force topic. On the basis of force topic. Now your homework. Time to give you a homework that you are going to solve at your home. So a homework so boys and girls, homework. M equal to 5 kg, U equal to suppose 10 meter per second, after time t equal to 10 second time, final velocity v is 20 meter per second. Now my first question, question number A. What is the unit of force? Unit of force. Question number B. Why push is one kind of force? Then question number C. Find out applied force for this case. Question number D. If final velocity is 50 meters per second, then are there any variation of force? Explain mathematically. So, all of you, thank you very much. Thanks for watching my today's lecture.